Right, first things first, hold that down for 10 seconds, hold it down for 2 seconds. It's difficult to get the timing right. And wait a bit. Hear that clicking? That's because I've just synchronized the socket to the remote control. But of course the remote control isn't there, I've taken it to bits, the actual controller is there. Let me explain what I've done. There's the two outputs from the controller, switching two MOSFET transistors, which in effect are pushing the buttons on the controller, and that is controlled by an Arduino controller, and that enables me to switch mains remotely. At the moment I've got a simple 1 second on, 1 second off program running. Let me see, I'm also thinking of using a different MOSFET to that one there. I haven't yet tried it, but that's a signal MOSFET. These are expensive ones, normally designed for switching on and off electric motors. Now, as it happened, my computer decided to do a restart, so I'll have to reload everything up. See, this thing is the buttons, and the buttons are just conductive pads that connect on the conductive pads on the back of the board. Now, I tried going straight from the Arduino to the inputs of the chip, but it didn't work. Significantly, the negative of the MOSFET is on the what would be the negative side of the button. You have to measure it with a meter. The positive side is is connected to the higher voltage, and the gate is connected to the Arduino. And I think bizarrely they call the negative the source and the positive the drain, because of a conventional electron flow. But as you can see, it's listening to button pushers. Now, this thing is still booting up. So what I did was I went to, I don't think you can see this, but in the examples there's a file called Blink. Called Blink Basics. Blink. Now you probably can't see that, so I'll have to talk you through it and let it boot up. There it is, and it literally winks the LED there, LED 13, on and off. Well, what I did was I changed it to, let's load in the new file, sorry, wrong one, open, and sorry if it takes so long. Yeah, this is a Byron socket, so I've called my program Blink Byron, or Sketch as they call it. Now, I don't know if that comes up. Oh yeah, it has, great. Oh, you can see that, I think, I'm not sure. But instead of having one LED as 13, I've got LED 1 as pin 7 and LED 2 as pin 8. I should have really called that button 1 and button 2. And then I've got the pin mode there, I've got the extra line, so it's LED 1 and LED 2. Now this, down here, the program loop is turn LED on, delay, turn LED off. On my one it's turn LED 1 on, delay, turn off, and then turn LED 2 on, off. Well, as I say, it should be button 1 and button 2. So what's that doing is pressing the alternate buttons. The delay is on for 1/10 of a second. Don't make that too short or the controller won't respond. And then 0.9 of a second. So that's 1 second, 1 second. So it's like a ticking clock. And that's just to check the technology. I could have it responding to sensors and set. You know, you can buy things that respond to sound that go with the Arduino, so you can make a disco controller. I mean, there's a mechanical relay in there, and if it's going all the time, it will eventually wear out. But these things are cheap enough and readily available, so that's not a problem. Especially as I'll only be using it for Christmas lights and special occasions. Now, really, you do need to know how to program an Arduino. I can't really take you through any more of this. I'll blow the program up so you can see it. I hope I can get this on camera, but you know, pause the video when you're writing it. And some of this is a bit irrelevant because it talks about turning an LED on and off. I should have really rewritten it to turn the button on and off. But there it is. Now let's draw the circuit. Now there's your controller. There's your remote control with the buttons on it. I've taken it apart, so I've got the circuit where the kind of spirally pad things where the buttons sit. Now you just go across them with a meter and you find the higher voltage side and the low voltage side, which when there's no button pushed is roughly 3 volts and 0 volts. So if you're assuming that's one of what would normally be one of the buttons, let's draw the circuit. Sorry. There's your MOSFET, drawn very simply. Now there's a negative pin on here, and let's make that the positive pin there and a negative pin there. Negative pin goes to the Arduino, negative. There's your Arduino. The positive, I found the positive on the back of the regulator there, so that's a positive, say. Sorry, I'm making this up. There's a positive. Now this got a 12 volt battery normally goes there, little 12 volt battery. I've got away running it at 5 volts. And then obviously I guess the range is down. If you decide to put the 12 volt battery in to get more range, take that wire off, because otherwise 12 volts will go back through there and will try and power the Arduino off 12 volts, and I don't know if it'll survive that treatment. So if you're building that, having said that, if you plug the Arduino into a 12 volt supply, you can take the 12 volt off the back of that and off the back of the plug, and that will give you your range back. But again, I can't guarantee it'll work or that the voltages. That's something you just have to experiment. Anyway, I've got pin 8, say, onto the FET. Now, the reason why it's done like that is that I tried going straight to the button. It didn't work with the positive side. What this does is that when you get a positive there, it pulls that down. It also pulls that up. It pulls a current through the two pads. And I believe how the circuit works is that one side of the switch goes to a circuit that turns the remote on, and the other side goes to a bit of circuitry in a chip that tells it what button has been pressed. So you need to bring them both together, and that's what the FET does. You put a positive on there, no current goes in there because it's a FET, it's field effect. So you basically get a current around there, and that current around there is enough to pull those two together, and that is half your circuit. And you see I've done it here with 2 FETs. There's the negative pin of each FET going to the negative pin of each button, as it happens at channel 2. The positive in this particular case is common to 4 buttons, so the 2 buttons are part of the 4 are common on there. That's not always the case. In some of these cases the positive is common only to certain buttons, and you'll need a separate positive to other FETs if you're using other buttons. This is just 2 channels. This is just 1 channel on and off to demonstrate the technology, and those are quite expensive FETs. One end, quite expensive FETs, normally designed for switching on and off electric motors, and they're well, I can't remember what they're called, what FETs I've used, but they're just standard FETs. They handle quite high power, so IRF series FETs they are, RF50 or something, but RFs they are. Now let me show you something. What I'm planning on using are these. Again, I haven't tried 2N 7000 N channel FETs. They are much smaller. I can buy a whole 50 of them for £2 plus postage, and that's about the same price as one of those. So you can see the reason why I'm buying cheaper ones, and then I'll build the whole circuit, and each channel, including the master on off, will have its own output, and there should be enough outputs on the Arduino to switch them. You can always go to the bigger Mega if you don't have enough outputs. As it happens, I've only got 3 sockets, so I might not even bother with the 4th channel. Although, come to think of it, I am actually buying another set of these, so I will have another channel, so I will bother with the fourth one. And this means this thing can be, you can have sound sensors, light sensors, timing, anything on programming to the Arduino, and it turns off your remote control, and that enables you to switch mains, but you don't have to touch any mains wiring. Now the reason why I'm building this is my son wants to turn his Christmas lights on and off, and he wants to have a display, and let me see if I can find it. HRIS Christmas, Christmas. I should have brought this page up sooner. Let's see if I can Christmas lights house show. Let's do this. I didn't think I should have brought. This is the one. I think this is it here. Yeah, I'll left click that and I'll bring it up in a new tab. Yeah, I should have thought to bring this up before I started making the video, but I think it's here again as well. I'll go, come on computer, hurry up. It's because I'm looking at it with a camera, that's why it's being so slow. But at the time of the making of this video, which will be posted on YouTube, YouTube have linked themselves into Google Plus, and as I'm not a Google Plus user, I won't get any notifications if you ask me any questions. So sorry about that. So hopefully you'll just have to find all the information off here. Remember to use the internet itself. There's plenty of information out there to help answer your questions. And if you don't know anything, just start off like you would as a beginner, and then when you answer the questions, this thing has decided to stop responding. What a pain. You can progress with the circuit, but it is very simple. There's a negative of the MOSFET, which is not connected to the negative of the circuit. It's connected to the lower side of the button. Now, difficult to do this one-handed with a meter, but basically all you do is, there's your meter. I'll do this one-handed because I'm holding a camera. There's a kind of interlaced squiggle thing, and you go to one side of the squiggle with the one probe, and you go to the other side of the squiggle with the other probe. Although what I will actually do for the purposes of making the, I'll jam one in the negative, and I'll see if I can do this. And if you say go there, that shows 3 volt. That shows 3 volts. And if I go to the other side, it shows nothing. So the lower side, the one that shows nothing, goes to the what would be the negative pin of the FET, and the positive pin goes to the positive side. And then the signal comes in straight off the pin. That's the gate pin of the FET, comes straight off the Arduino pin. It's fortunate everything works out. You don't need any extra resistors or anything like that. And see, what happened is my son saw this house on eBay, sorry, on YouTube, and he loved it so much. He said he knows how to program, and he said, I want that house. I want my house to be like that. And he's got young children, so I thought, I don't want him messing directly with mains. So by doing it this way, he can program the Arduino, and he can do what he wants to do, turning the lights on and off, without any danger of him or his kids coming in contact with mains. And when we get past all the sordid advertising on eBay or YouTube, there we go. You got this. They got this amazing house. I've actually got the wrong one. I'll show you which house he saw. It was this one, but I'll try and get the right one. So I'll stick that on pause. Computer's being a bit of a sod, I must admit, because it's just how computers are. When you're trying to do something with a computer and you're trying to do it in real time, the computer just gives you hell. They have an urgency detector built into them, and the faster you need to do something, the slower they go. Anyway, this is the house, and so there it is. And it's not that this is a Halloween. There it is. And that's what my son wants to do. Now you can get multi-channel ones of these, and There is a remote they do, the different one, the slanting buttons. Let's turn the sound off. I'm trying to turn the sound off. There it is. There, I've turned the sound off. Oh, come on, computer. The mouse, it's not cooperating. It really is being a sod, sorry. It's locked up. Anyway, I've turned the sound off. And that computer locked up. Oh, there's the mouse. Let's try that one. Anyway, there we go. There's a Byron remote you can get. It's same company, same manufacturer, with slightly slanting buttons, and they goes with. You've got the answer with that. The advantage of that system is that you actually have a selector on the back, and you can select 4 separate channels, and you can have 3 plugs on each channel. And you've got little rotary detectors on the back and a little slide switch on the controller. I haven't taken one of those controllers apart yet, but I assume it probably uses the same button arrangement. That would give 12 channels to use use on individual channels. If you set it all up right, that gives you 12 channels. But you'd need 24 outputs, which means you would need the mega Arduino to do it. But or you just use more Arduinos. You just use different Arduinos and different channels because they're cheap enough and you have them talking to each other. And however you'd want to do that. This computer's locked up again. What a disgrace. And no, I think I've lost it. No, the Windows has crashed. Nothing's happening. Let's try. Let's see if I can get it back that way. Yeah, he really is absolute. You know, this is typical of computers, isn't it? You're doing something and it just messes up because Microsoft Windows are just so completely rubbish that you can't trust anything to do anything. But anyway, there you go. There's the house. There's the actual house my son saw. And look at all this stuff going on. And you can switch MOSFETs directly. These ones, the more expensive ones. I've actually got an Arduino here with one MOSFET transistor actually built onto it, but of course that's just one channel. What you can do is use a motor shield and plug into the motor shield. That gives you 4 channels, although if you ground, that gives you 4 channels you can reverse. And what you can do is let's draw a bit of circuit. Here's your motor shield, and it says there's 1 channel. Now what you do is one set of lights is there, that's a bulb, and you put a diode, which is a one-way valve. This is more sophisticated electronics now, one-way valve, but still very easy to do if you know anything about diodes. Let me find you a diode. There's a diode with the silver band. The positive flows from that way to that way. You can get smaller diodes, which aren't to hand at the moment. I'd like to show you smaller diodes. Oh yes, there we go. There's a smaller diode. You notice there's a slightly silver band to your left. I don't know if you can see it. And the silver band represents that band there. So if that's plus and that's negative, power will flow through your lights and the lights will come on. What you can do is you have another set of lights where that's the negative, and you see there the diode is like that, like so, like that, to your other set of lights. So when that's positive, that diode conducts and these lights come on. When that's positive, that diode conducts and those lights come on. So you can get 2 lights for 1 motor channel, and if that's a typical motor shield, you can get 2 channels of lights for every one of motor. And there's this remarkable house again, and this is what we want to achieve. And so this is some suggestions of how we're going to do it. It's early days yet. We're still early days ourselves, and nonetheless I'm going to see if I can find some more. I actually got a motor shield in very recently. Let me see if I can find it for you, so you know the kind of thing we're looking at. And there we go. Is that it there? No, that's a sensor shield. That could be very handy. That could give you a lot of output. You could have lots and lots of output pins with that, possibly. I've never used one of those, but that might give you a lot more outputs. That's called a sensor shield. And I'm going to try and find the motor shield, which I bought very recently and I've just chucked in the drawer. Now I've gone and lost it. And you can have all sorts of goodies. There's another. When I do an Arduino up, I put insulation on the back. So if you rest it on something that's metal, it doesn't short out. If you look there, it's just insulated. That's just to prevent the possibility of an accident. This is the kind of socket set, remote control socket set that I've adapted. It's the Byron Home Easy range, though they do seem to do two slightly different versions of it. And I'm trying to find that shield now, but it's, I can't, so let me look it up on the internet. Computer wants to cooperate. I'll see how I'll get the computer to cooperate. Let's get on eBay. Like you say, I'm not a YouTube user, so sorry, I'm not a Google Plus user, which means I can't communicate to you on YouTube, which is a bit of a shame. And so let me go MOTORSHIELD Arduino motor shield. The one I'm thinking of, my son's got it and I bought another one to replace it, but I've mislaid it. It's that one. It's that one there. And the shield is actually powered by the Arduino, but if you take a link off there, you can then power it externally with, I think if the power goes in there and there, the middle pin. And there's the channels there. That's one channel, M3. That's another channel, M4. And the other two channels are there. You can also control the servo motor off there, which could switch other things. This is the DK Electronics motor shield, and each one of those channels you could do the diode trick. That will give you eight sets of lights for one channel. And then let's just do a bit of exploring here. LED lights. So let's see, you could power it off 12 volts and have 12 volt lights. I don't know what voltage it goes up to, but you get these sorts of lights, you see, these kind of strip light things, and they're very efficient. They don't take a lot of current. In fact, as it happens, these lights come with their own remote control. I wonder, would it be possible to adapt one of those to be switched using an Arduino? But again, that's just a suggestion. Let me go back a bit, and there you see fairy lights again. And one approach is to feed them directly off a motor shield powered by low voltage, or at the same time then having other lights powered off these sockets for heavier circuits, for heavier, bigger circuits. And you can use a combination of the two. And of course you've got let me see, you've got that motor shield I've just showed you also does servo motors, model aircraft servo motors, which can be used to animate things, get powerful one and make things move. And so there's all sorts of possibilities here. But I'm digressing. The main plan was to wirelessly operate a socket from a remote control, and it's one of these. This is the particular one. So if you want to be guaranteed it's going to work on that circuit, this is the one you're looking for, the Byron Home Easy. And this is what it looks like. That's what it looks like. I'm trying to put it together one-handed. Those buttons aren't going in, but the buttons basically drop in there, and there we go, and it goes a bit like that. So that's what it looks like. Look up one of those on eBay. Little battery thing that clips on there, and that gives you what it should look like on. Yeah, there's the battery thing. So what you're looking for is one of those, the Byron Home Easy remote control. There is another one they do with slanty buttons, and that comes with the the mechanical channel selectors. That may be going out of production because I haven't seen so many of them recently on eBay. But there is a dimmable one where you hold one button down, it gets dimmer. You hold the other button down, it gets brighter, and that's how it works. And there you get. But even though they're both the same make, I don't think they're compatible. I think the ones with the mechanical selector and these ones with the button where it learns which channel you're on are actually different. One thing I will say is when you have set it to a channel, even if you remove the mains, it remembers what channel it was set on. Some lights don't do that. Some of these things you have a learn button and you set it all up. And if the mains goes off and comes back on again, it's forgotten the channel it's on, which is a nuisance. Fortunately, these don't do that. Now, you could even have two. You could have one controller controlled by your hand controller, which acts as a master switch on-off, and then when you switch on the one that's turned on, when you switch on the master one, the second one is controlled by your Arduino, and then can switch on and off. Will switch on and off your lights. And what that means, but the master one has to be powered on all the time, because if you put it into the one that's switched by the computer, it'll drop out. You need that master one to be in there. You turn on the master. This is transmitting, of course, and what that means is you can have your lights going on and off, but you can also control them override off individually to add to the variety. And so you'll probably end up buying several sets of these. You'll have one remote of your own, you'll have another remote wired up like this, and let's get the circuit out of the way. I'll leave the camera focused on it, so if you're actually trying to copy the circuit, it's there it is. I've actually just scraped off the, if you're clever enough, you can actually trace it back to the pins on the chip and connect all the individual pins, but I found it easier, less likely to short out, if you just scrape little bits of silver off, little bits of screen, the green screen off the wires, and just solder straight onto them. And so there's your circuit, and basically you just put a MOSFET across each switch connected to an output, and then you power it off there. This is running this at 5 volts, which have reduced the range it can transmit. If you run it off 12 volts, it will transmit greater range, but just make sure you don't get 12 volts back into the Arduino. You might blow it up. You'd have to take this wire off, or even use a diode or some other arrangement. The only thing is, if you put a diode in there, that'll drop the voltage a bit still further to this, and I'm already running it under half voltage. It might not work at all, so that's why I haven't put a diode in there. But a run back diode would stop the possibility of any volts applied there getting back through here. But that's a refinement. Funny thing is, normally when you build a circuit like this, you need to add extra resistors and diodes and things to match everything up. It just happens that the way everything is here, you can get away with just a MOSFET. That's all you need is a MOSFET. Now, all you need is a MOSFET. Having said that, if you're building a board, you might want to put a resistor and an LED in there, so when you're switching the channels, you can see which channels you're switching on, and that's so that it helps you with troubleshooting. And so you might want to have channels switching on, LEDs lighting up, just a little simple circuit. That's a 1K resistor, and to give you output indication. And when I build the thing on breadboard with the lights, this is very fine wire. You actually need quite fine wire. I think it's actually kind of like this kind of flex, this kind of 4-core flex that's had the wire stripped out of it, and it's here's a bit here, and you need fine wire because it's just difficult to get on there otherwise. You do need someone that's good at soldering. It's too much risk of making a mess and shorting things out. As you're putting it together, test and test and test again, so if something is not right, you can track down where it's not right, or expect it to be working. So for instance, when I put this together, I I put those on, soldered all this up, and then I shorted those pins together with a screwdriver to check that the remote's still switched. And that's before I even connected the Arduino. That helped me guarantee the circuit was right, so there's no danger of me shoving anything back into Arduino and blowing this up. These FETs are wired. There's your MOSFET transistor. There's the hole. There's your 3 legs. And you see that's those 2 black things there. Now that one there, that pin there, that pin there is that pin there. So call that pin 1. Sorry, that pin there, that's pin 1. And that's going to your button on the negative side of the button. That's pin 1. Let's say that's pin 1. This is seen from the top. There's writing on there. Pin 2 is that. So there's pin 2. And pin 2 is there. Pin 2. Let's call that pin 3. That's the gate. That's the signal that turns it on and off. And pin 3. Here's pin 3 there. Obviously, if I'm talking too fast, just pause the video and run it backwards and forwards. I am actually deliberately rambling on in order to try and give you as much information as possible. And the reason why is because obviously I can't comment or respond to my videos anymore, because the way that YouTube now runs through Google Plus, and I don't want to be in Google Plus because I'm quite happy with Facebook. Thank you very much. The last thing I want is another social networking site to be occupying time. Someday YouTube will be sensible about things and allow people to comment on their videos directly, on their own videos directly, and respond to comments. But for now, they're having a bit of a crazy idea, trying to put it all through Google Plus. And the stupid thing is, Google Plus and YouTube were never designed to work together, and so it's just causing a lot of aggro and hassle. Hopefully, common sense will prevail, and we'll once again not have to go via Google Plus to comment on the YouTube channels. But unfortunately, until that day comes, and I can't post or I'm not notified when somebody posts on any of my videos, because the YouTube notifier has been stopped. And even if I am, I can't comment on my videos anyway, because it has to all go via Google Plus. One of the things about Google Plus is they insist on you using your real name. And of course you don't want to do that for reasons of identity theft, and so I'm stuck with my silly YouTube name, which is different, because again, it's to stop identity theft. Google Plus insists that you use a real name rather than something silly like Ding Dong Merrily on High. And then when you use a real name, if that real name just happens to be the same as somebody else's real name, and their actual real name, not your pretend real name, they can accuse you of identity theft and shut down your YouTube channel. So, and if you've used an alias like I have done to protect yourself against identity theft, you could end up losing your YouTube channel. So whatever way you look at it, the Google Plus YouTube idea is a very bad one, and therefore I'm just going to stick with YouTube on its own, because I've got a channel with some 500 videos on it. I can't take the risk of a malfunction on Google Plus causing my whole YouTube channel to go down and be lost. That's just too great a risk, and nor can I take the risk of using my real name on the internet, because that's basically a license for identity theft. Anyway, I digress. You can see there's all sorts of wonderful stuff around here. Aladdin's cave of wonderment and science, and tons of Arduino stuff down there. I've got a 3D printer coming that's going to sit in that space. Power supplies and all sorts of marvellous kit, but I digress. I've said about as much as I can, but I'm just sort of rambling on because I'm going to use up all of the 10 minutes. And while I'm rambling on, hopefully I'll think of other things to say. If you're not very good at soldering, get yourself a solder cleaner. That makes all the difference. You see that thing I'm jamming the soldering iron into? Get yourself a decent soldering iron with a fine tip. temperature regulation on this isn't very good, so it's because it's not an expensive iron. But fortunately, being an experienced solderer, I'm okay. Make sure the sponge is wet, that's absolutely critical, and use it. See how nice and shiny that comes up? That's really important. Soldering is a real art, and when you're doing something like this, it has to be a first-class art. You can see there, literally, I've just soldered the negative onto the socket in, and I'm just soldered onto the, hang on, let me move the negative wire out the way. I've literally just soldered onto the back of the board there. I've done that because I'm relatively experienced. Most people actually plug in a shield, even just an empty blank shield, and then connect to the empty blank shield. That might be a better thing to do. You might even be able to build all the transistors on top of the blank shield. In fact, that is a very good idea. Let me unpack something. Bear with. You might be able to, hang on, I'll be as quick as I can. Right, here's a blank shield. Now there's a stick-on little broad breadboard thing, so you can stick that on there and use that, or if you can actually solder, you can use that. And I will put all the little FET transistors into here, and we'll wire up onto this, and I'll wire up onto this, and I'll be able to well, yeah, I'll use one of these, and I'll use those little transistors I showed you earlier. And where are we? I'm going to go back and try and find them. Those MOSFET transistors, and there's the motor shield we're talking about. Let's go back. Let's go back there. Those things, and I'll set all those up in there. Going to be tricky because ideally I need an output and a gate, so I might just actually have to put them on the blank area and then just run little links across it, just join them across on the back. And when I've finished, in fact what I might do is not publish the video until I've made it and do it as an addition or a follow-on, or rather I'll make another video when I've done it and got it working, and then have a follow-on video to the one that will be on YouTube. So when this is built, under the video you'll be able to click on you'll be able to click below and there'll be a follow-on video. And so I'll do that, so don't try and ask me, have you built your multi-channel one yet? This is a single channel, just a test, because when I've done it I'll put that extra video on and link to it. You can't ask me because, as I said, I'm on Google I'm not on Google Plus. And as you say, this is very early days, just to get the suggestion. And you say I'll use this. You probably could use ordinary transistors actually, but FETs, the problem with ordinary transistors is that they do pull a gate current, which means you will need a resistor in there, and even then I can't guarantee that the gate current, which will leak through the controller, will actually cause the controller to not function. So MOSFETs are actually better. I can't guarantee that the 2N7000 N-channel signal MOSFETs will work, those ones, but that will be as part of an update. As you can see, as an experienced electronics engineer, I do tend to solder stuff onto Arduino boards. That is not how you're supposed to use them. You're supposed to use plug-in shields, but as you can see, my Arduino projects often have the Arduino itself as stuff soldered onto them. But I say that's unconventional. Normally you'd plug a shield in, but I'm reasonably confident not to blow things up, so I do tend to just build straight off the board. But you know, there's an Arduino with a shield plugged into it. You could have the shield underneath this shield with your transistors on it, maybe another one on top with transistors on it, and then say a digital display shield with buttons and other this is a Sane Smart one with your digital readout. You can even get shields that can talk by text message. This here is an SMS shield set, and it's in here. There. Oh, there's a motor shield I was looking for. This is the advantage of rambling on. You find things that you didn't. There's the motor shield I was talking about. Bear with, let me open the packet. Packet's very strange, hard plastic. It's very difficult to get started. There you go. Yeah, there it is. There's the motor shield. I can do that trick with. And but what's really of interest is this. This is. Let me open the packet. And touch something grounded, and it could be a static issue. But this shield, complete with this aerial that's just come out of the packet, is a SMS shield. You'll be able to text message this, and you'll be able to turn things on and off my text message. And your SIM card goes in the back there, and this will tell your shield, this will enable you to control your Arduino with your mobile phone. And that is marvellous technology. That's quite an expensive board, that. And that is, I haven't really looked into it very far, and I don't know whether your mobile phone is designed to talk to this, or whether this is intended to talk to your mobile phone, or both. I probably assume it's both. I see jack sockets on there, so that's interesting, whatever they are. As you say, I've just bought this. I haven't really looked into it, but it might enable two-way communication with a mobile phone. That will be a project I will have a go with next. I think I'll have a go with that next. I've got this little thing. I might be able to just do something and get it to turn the one channel on and off while I'm waiting for my transistors to turn up. So again, that's another possibility. I like to solder things together because I'm experienced with electronics. You can use breadboard, just use links. You know, let's demonstrate. You see what I've done here with all these wires and all of this business? What you can do is, let me get out a MOSFET. There's your MOSFET, and you put your MOSFET in like that. Sorry, I'm not aiming the camera right. There's your MOSFET, and then you can, I think I'm going the wrong way. I think it's like that actually. I can't get it in there. And all these strips are connected vertically to each other, so you can just connect breadboard. You can connect to the pins by plugging in little leads. Let me find one for you. See, these leads come in the kits, and you've got the little probe, and you just plug the probe in, so you can plug probes in like that, and then you can plug the other end into your sensor pin in the Arduino like that, and you can plug things together. But of course it still doesn't, but you still need to get onto this, so you will need to solder. You know, you might have an experienced friend solder up that board if you want, and then you can just put stuff in the breadboard. That's just a suggestion. Now, that's again be a little bit careful with static precautions. So put all this away off to one side. And, so again, yeah, I've covered the main basic subjects, but I'll just carry on rattling because people will have questions, and hopefully as I brainstorm I will find the answers to those questions. I believe these strips are all these little connections are connected in strips vertically. They may be horizontally, but I think they're vertical. I'm not sure. I haven't actually used one of these before. I have used bigger ones, but I haven't used this one. It's called breadboard, by the way, that stuff. And that's a little one designed to sit on top of that blank shield, but I won't bother. I think I'll just solder the stuff straight in because I've got the equipment to do it, and it is a stronger, better, more reliable way of doing things. Stuff tends to fall out of breadboard, and so I'll have these transistors. It won't be these ones, it'll be the much cheaper, smaller ones, and I'll just have them stacked up like that. I don't think I can put, I'll just have them, I don't think I can put them on here because these things will just short two of the pins together. What I need to do, I think, is, no, he's actually going to take some short. I think I'm just going to have to stand them on blank pads and then put fine leads on the back like I've done here. What I'll do is I'll bend the ground pins. No, I can't. I can't do that. all of the pins need to be independent of each other because of the way this is. These buttons, there is no common line that goes around, so I can't common either the positive or the negative. It's done, some of the pins are common positive, common negative, so if you just run a wire from each one you can't go wrong, but it does mean you will have a lot of fine wires. Where if you do see the common pins, then yeah, by all means common them. Where they're common on the board, just use one wire and common them at this end. There's no problem in that. That works. I've demonstrated it works there. Oops, sorry, I'm waving the camera around too much. I'm rambling, and I hope it's in focus enough. But again, I'm just adding extra information and suggestions and general brainstorming. So, you know, feel free to think about it. Anyway, the main thing is, going back to the main subject, let's get rid of all the junk, is this is this circuit here. Let me find it, let me put it on a white background. Hang on. Difficult to see what's going on, but it is a very, very simple circuit. I mean, I have rambled on onto more complex issues, but this is a very simple circuit. There's the, as it happens, the positive pin was commoned on these two buttons, and the negatives were independently switched. On other buttons, you'll find that the negatives are commoned and the positives are independently switched. So it's just simply a matter of those two pins being joined and those being individual wires. And so it's but again, if you just run individual wires, you can follow the tracks through on the board. What you've got, and you can't really see it, so what you've got is each button is a pad, and there's your circuit. It goes off your circuit, and this bit of the track is black. It's got a kind of carbony coating on it, and then there's another bit of the track that's like that, and that's just that bit there is your normal green circuit board track, which you can scrape the top off and solder onto. When you scrape it off, it goes copper coloured, and then the bit that's actually interlinked goes black. So that bit there's green, and then that bit's got a conductive black coating on it instead of the green insulation, and then that bit there, go around there, that's got the black conducting stuff on it, and then that bit there is green, and you can just scrape off the solder there and scrape off the solder there. I don't think you can solder to that bit, although you might be able to glue onto it using wire glue. Got very fine wire, you could probably wire glue, special conductive wire glue would do that job. You could do it that way if you haven't got a soldering iron, and then use plug-in pins and stuff, but again you have to be careful. I've got another 15 seconds left before I run out of video, and I don't think the camera's going to stay running for much longer. So there's your both of these are actually managing to click on and off, which surprises me, but there it is. You can hear that doing its thing. And yeah, so as I say, I've rattled on, and I'm about to run out of video, I think. And so when it times out, I'll put it on YouTube, and I'll do a follow-on video, as I said. And you can see this is acknowledging the fact that the button's been pressed. There's this sits like that, you see, and that LED pokes through that hole there, and let's try and line it up. There you go, there. And so effectively all I'm doing is I'm just pressing the buttons, and it's actually on channel 2, this one, for no particular reason. And as you say, I'll do a follow-on video which will be linked to in the text and this one when I'm ready. So if it's not there, I'm not ready. So save you asking about it. But yeah, I would like to see, if you can comment on the video, please do, because eventually I'll get around to looking at them sometime in the future. It'll be nice to see them. I may, if I come across the video in my selection, I'll be able to see the comments. But obviously I'm not notified of them. I've got so many hundreds of videos out there, checking them all would be ridiculous. But yeah, I'll when I post a follow-on video, I'll be able to read any comments. And I hope the camera work is okay. I'm a better electronics engineer than I am a cameraman, so and I know I can be a bit wavy camera about when I'm talking, so hopefully I haven't driven you too round the twist with super shaky wobbly vision. But you know, there's your circuit, and there's a circuit right there, and just have one